Hello everyone and welcome back to another video. So today I'm going to be talking a little about some stuff that I've been working behind my project and some updates. So I have been reworking the game data for my game, the way that I handle the import process for game data and how I'm building the information data for my project. I am already working with loading assets through the game data towards the game and actually placing them inside the game. The last step here would be to hook up the animations and stuff to deal with AI logic for NPCs and such. So the way that my system is working is that I have the information from game data here, which I'm working. And as you can see, I pass some information and this information is imported through Godot and it's actually being converted here to an integer. So there's a lot of stuff happening here. And I can show you the code for that. So I basically redid all the code for the import game data because I was having a lot of trouble with my previous implementation for stuff that I did not show in the video. So if you follow the last tutorial on game data, this is pretty much close to what I did previously. So all I'm doing here is treating all that information from the CSV game data as a dictionary. So everything you see here will be imported as a dictionary, which each column being imported as a dictionary entry. So the way that works is that once that gets imported to Godot, you can see here what that looks like. I am actually building the game data once you start the game, which is the way that I was doing with the last tutorial. Because here's an older version for my project in which I built an add-on to build the game data inside of the editor. And this was a super hack way that I found to replace scripts in real time through the editor to build the game data. And I thought I needed the game data to be available in the editor. So I built this method to have the game data being displayed right here in the editor. And this was super hard to do because I have to build this script in real time here in the editor. And the way that I did that was by creating this module script builder. So the code that you see here was responsible to grab a template. So this will be the template that the script was going to start with. And I was importing the CSV information from the CSV data files and being stored somewhere. And with this module script builder, it was finding keywords and replacing the columns where I knew they were a dictionary with the information being imported from the game data. So this way I could have the game data being built right here. And I simply call this through an editor add-on that you can build. And this is basically the code for the add-on. So it's pretty basic stuff for add-ons and stuff. But this is simply the way that I did to build the game data inside of the editor. So I thought that I need this, but this turned to be much more complicated than I wanted. And I simplified it a lot and basically scrapped all of that. I no longer am building the game data through the editor using an add-on because I actually don't need this. I thought I was going to need it, so I coded everything, but it turns out I did not need it. So instead, the game data is being built once the game starts. This way, I have a much simple workflow to deal with. And once I started to use the game data, you're going to see how this type of thing is going to be super important for the game. So this is the backbone for the structure of your game. And if your game uses a lot of data and you don't have a good system to deal with that, you're going to have a lot of issues. And I could do that manually by creating objects using scenes, self-contained scenes. Like if I wanted a mech unit, I could load a mech GLTF, add the material, then export it as a scene. But you have to do that through all the units. And the advantage of using the CSV information like this tabular data here is you have everything here at your fingertips. Everything you want to change is basically replace and it should work appropriately. So you're going to see here that I'm using some information. So I have an asset path and a material path. So if I wanted, I can basically swap materials with the same 3D assets. So there's some code that is being imported through this, and I want to show you that. So regarding game data, basically, I have restructured everything. And this is the final version of my game data. And the code for that is simply this here on the module data compiler. There's a lot of stuff happening here, but it's not that complicated. This is work that you can find on the building game data stuff. I code this from scratch, and you can follow that tutorial, and it's almost the same approach. Just a couple of things are different here. For instance, I am not using strings. I'm using enumerations because integers are faster. So if you see here that the headers are being converted back to integers, and the way that I found you can convert strings back to enumeration headers is by using the get function. So the get is going to grab a variable from a given object. And on my auto load here, I have an object data enumeration with a bunch of integers here. And once I get the header from the CSV from string information, so this is string information. Once you do a get asset path inside the game data object with the enumeration and you do a get that asset path, it's going to actually return the enumeration for it. So you can see that asset path is right here and it's number 8. So that pretty much is to speed up the data stuff. So if your game is planned to have a lot of data, I think it's a good practice to get rid of strings for dealing with stuff that you can avoid. Of course, paths towards places and stuff, you're going to use strings, but that's is part of the game data itself. So this is pretty much how I'm doing it. So this is everything I have planned for the game data. I think my system now is much more robust and simpler than I had, and it's going to work much faster. So having done that, let me show you how you can actually import a GLTF from a save file. So you can see here I have a bunch of 3D resources for testing the prototype of this project. And if I open here my game data, you're going to see that the path that is being placed here, so GLTF RTS base soldier, is right here. So on my project, there is the GLTF base soldier 1.glb. So units that have that prefab ID, so you can see here. So what is prefab ID that I have defined? So this is some idea that I saw in another game. I don't remember which one. I think it was one of the classics RTSs that they use prefabs to define a like a template to our units. And the way that you can do that is by, let me grab here my units. And I think I have an export variable here for editor and stuff. And I'm actually exporting a unit prefab list towards export var. So for you to create this drop-down menu here with a given set of values, you simply do an export variable and you pass that variable. So the variable that I'm using here is on game data with the unit prefab list. So the unit prefab list is just a simple enumeration here that's being set to have the ID for these entries. And the funny thing is, these values here is actually the line of the game data. So you're going to see that my Mac units is on line 6. So here you can see the Mac units is on line 6. So that is also part of the data compiler that I changed, that I'm actually parsing lines as they are. So for every CSV line, I'm actually adding an iterator through it. So talking about loading assets in the units for the games, I believe on my RTS unit code for basic units in the game, I have a unit process prefab data. So this is where stuff gets interesting. So whenever we start our object, we're going to basically wait for everything to be ready, and we're going to initialize the units. The part that the unit is going to initialize is going to first teleport it to the navigation polygon, so it's going to stick the unit to the ground. Then later I'm going to set stuff for the region grid position, which I talked about on previous tutorials. Then we're going to set up the prefab data. And this is the place where we're going to be applying the game data back to the units. So we are going to first load the prefab data, which is going to basically fetch all the information we set up. So in Godot, once it has been built on the auto loads, we're going to fetch based on that prefab ID. And we know the ID based on the line that was on the game data. So once we load that, I pass an array of all the object data stuff that I want to add to the units. And for each set of that information, I'm setting the object data back to the units. So the object set data is a function that's simply setting the dictionary values. And I want to put some logic here, and I want to avoid doing a set get for object data for everything that I want. So the way that I found to do that, as you can see here, some placeholder from previously, where I would store all the data for the objects, I want to have this as a dictionary, and I don't want to use a set get for every time we change the dictionary. So instead, I'm actually doing through a function, and if I want to apply special logic towards a given data type, I can simply set it up here. For instance, I give here an example. If we set the HP to 0, we know that the unit should be dead. So this will be the case where it would be nicer to add a set get information here. So how you're going to load a GLTF from a given path and put it inside of Godot. So once I load my prefab data and I set all the object data, I'm also doing a process of prefab data. This function here is actually going to process the information we just loaded for our object data. And as you can see here, we have a unit asset path. So this is the 3D asset path, and we grab it from on the object the game data towards our asset path. And once we have that, we're going to load a package scene with that asset in here. So the way that this works is that even if you're doing a load function for every single unit in the game, Godot detects the same resource and is actually increasing the ref count instead of actually having to load every time the units. So this, I think it's going to be only called a few times, like 1 or 2. And once Godot identifies this as being a resource, it basically reuses this. So it's not actually loading for the 300 units we have on the map the same scene. So the way that this is working is that it's grabbing so let me grab the example using the Mac. It's grabbing the assets and it's actually loading it as a memory. And here you can see that I'm actually creating an instance from that loaded scene, which is our main GLTF 3D scene. And I also instantiate it as a node 3D. Next, I grabbed the asset node 3D material and the animation player and add it back to the scene. So the way that this is working is that if I make this local, I am basically stripping away this first node here because I don't want to spend resources on an extra node for every single unit. So the stuff that I needed, and I talked about this on the previous devlog with regarding structure to the assets being imported from Blender, I only need this information here. And because animation player, the animation data is being stored using, like for instance here, you can see that the path that's being using is actually the parent, which is this guy right here. We have to use this node as well. So the way that this works is that I'm actually stripping away only these nodes and adding it back to the RTS units. So, and this is the code that does that. So if I minimize this, you're going to see here that I'm grabbing the animation player from the GLTF main 3D scene that I have instantiated, and I am duplicating using instantiation. This flag is important to not have duplicate information with the resources. So we are duplicating the nodes, but the resources are kept as an instance, and this is to help performance. Be very careful with duplicating a lot of nodes in Godot because you're going to be able to create a lot of unique resources and you can screw up performance. But doing this way, you actually use instantiation, so all resources are being used are the same. So I grabbed the animation player and the mesh 3D from the GLTF main scene and the other one from the main scene, the first child. So I know the structure of it because of the GLTF. This is the structure that it comes up with. So the first node is the node that is going to contain the 3D asset, and the second node is the animation player. If for some reason I have a different structure, this code also needs to be updated. Then I'm adding back to the unit that is executing this code, the asset and the animation player, and changing the roof node for the animation player back to being this unit. So you do a get path for that. So this way, all the animation information is also going to work as expected. And I'm also loading the material from Gamedata. So as you can see here, we grab the mesh material, which is a variable that I have right here. That is being assigned towards the material, which is being loaded with the material path that I passed on the Gamedata here for the given units. So this way, if you want to have different materials for the same units with this, let's say the same 3D appearance, but a different material, now I have this control over here using the Gamedata, and this is how it works. So as you can see, this is how I'm loading the Gamedata towards my game. And if I go back here to the unit here, once I initialize it, that is basically what I'm doing it. And lastly, I'm only checking the setting the faction. So as I'm building this towards the RTS project, I think that the object game data stuff is going to be pretty important. So that's everything I'm doing. The last thing I want to show you is that I have created a new folder here to separate the materials, so I have the information to type here on the game data. So I could create materials through script coding, but I think it's much easier for us to do it inside of Godot. So you pass through a shader and a couple of images, and you save this as a resource. And the way you do that is by, once you have, let's say here, this mesh, once you have a new material or a new shader, you can basically click here and do a save as, and you're going to save the material as a resource file. And I'm basically saving it here as those materials. So the idea is for us to have a couple of materials per unit, and I can basically change them here through the game data and stuff. And just by changing the information here and exporting it back to my project, it's going to be imported through the data game files and being built inside Godot, and we could be updated and load and inside of the units. And this will be the same approach for all of the other things inside the game. I think it's much easier to deal with the game data inside a spreadsheet than using custom resources or the other tools that Godot gives. So this was a lot of work to set it up, but now I have a working system to import the information directly from the spreadsheet towards inside my game, which is, so if I run my game now, you can see that everything is working as it should. So now my objects are being imported, and you can see that they have the units being loaded, the assets as they are, which is pretty fun stuff. So this will basically be the way that you're going to be import a lot of different units, and once you start the game, you load them up. So as you can see, this is stuff that we are actually building towards our RTS game. Something I want to talk about is regarding object groups. So I talked this about in a video on principles, but here is the appliance of, here's how I basically apply that principle. So you're going to see that on my RTS map world, which is the node that is responsible for dealing with a lot of stuff regarding the maps, the units itself and stuff, it's going to hold an object groups, which is basically objects with their ID and a null value, because I want to use dictionaries, not arrays. So arrays are faster to iterate through, but because we are building these dictionaries, these groups, and at any time, any given unit can exit or enter, I basically decided to use dictionaries instead. So I have here, for instance, a group that is selectable objects. So regarding, we have two types of object groups, I think, for now. We have object groups that are what objects are. So if I go here on my objects node, so let me minimize this stuff, you're going to see that I have here buildings, units, resources, and decoration. So I want to place unit nodes inside this units tree node here that belongs to the RTS map world. So I know that objects inside that are units, but then it begs the question, are all units selectable? So if they are inside the selectable objects, we will be able to select them. So the information that is being passed through, let's say, the player interface to select units, for instance, whenever we pass the mouse or we press somewhere, I'm passing that group, the selectable objects from the RTS map world back to the player interface. And I have created a constant that defines what types of objects are selectable. So for instance, I could have a resource or a decoration object group, but I don't want it to be selectable. The way I'm doing that is by not including on the selectable group array. So if our player interface requests this group here, so whenever one of these groups changes, we're basically changing it. So let me go by here. And you're going to see that I connect a bunch of signals to do that. So the idea that is for me to maintain these groups are, once a child object has entered a group, like this node right here, I'm going to use the enter and exit signal from the nodes to generate the groups itself. So whenever I delete a unit using the kill-free method, it's going to exit this node right here. Once it exits, this is going to emit a signal back to the RTS map world that's going to remove this object from the given group, which in this case will be object buildings. So the way that works is through a function that I'm calling here for the RTS map world, I believe on ready. So after I've set up a lot of things, I'm executing this function. And this function is basically generating a temporary group here for all the 3 nodes that I want and what is the enumeration that's being used to create the groups itself. And here for every 3 node that is present on the group keys, which are these nodes right here. And these are nodes that I'm actually using. So as you can see right there, for each single node that is inside the keys of that group as an array of nodes, I'm actually iterating through them and first grabbing the group value here, as you can see. And so this will be actually faster than use groups given by Godot because it only uses strings. So if you wanted to create a group system with this is basically a dictionary of objects that are being saved under a integer group ID. So this will be much faster to work with. So the groups array is basically this. So here I have a conflict with some ideas. So I want to use the bind to the child enter for that 3 node to be able to add or remove nodes. So the child enter or exit signal for the node is going to pass the first argument as a given node. So I have a function here, the group set node for every single object group that I have. And the first argument will be supplied by this signal, which is going to pass the node. So that is why I only pass only 2 other arguments. The first one is already being supplied by the signal. So bind is basically being able to connect only one function through a specific signal. So the way that works is if that selection group, so if the object group that we are passing here for the 3 node, which is grabbed from this guy, if it is inside if that object group is inside of the selectable object groups constant of this node, I am basically added to the groups array argument to be connected to the signal here on bind. This way I can have an object belong to multiple groups at the same time through the same signal here, which is the child enter signal. So this is the way that I'm doing it. And after I'm doing all of that, because there are nodes that are being added through the editor, I have to initialize all of them. So I basically re-emit a signal child enter 3. So I can run this function here. So this is everything that I'm doing to build and maintain groups. And if I run the game here, we can see that in real time. Let me just minimize that. And if I go to remote, to my project, and go towards the world, you can see here we have object groups. And it has a couple of enumerations here, which follows just as this one. So we have here the module RTS selectable objects group. So this belongs to a module. The module RTS world enumerations here. You can see that 7 is going to be the selectable groups, which is this guy. Resources is going to be 6, 5 is going to be buildings, and 4 units. So these are the lists of all the objects that we have on our game that we can actually select it, and they are encoded as an object ID. And the value for the dictionary is null because I don't need the values, only the entries. So this is how I'm choosing to deal with object groups inside my game. I think this is faster than use a string-based approach, and it allows me to maintain groups just by the fact that I'm adding nodes inside the 3 nodes of the objects right here. So this is much nicer to work with. So this is how I'm handling it. Object groups can be used for AI logic through scripting logic, where is the logic for the player interface to select the units and not select others. For instance, decoration props I don't want to be selectable, so these can be on a non-selectable group that is going to be defined on the RTS map worlds here on the selectable object groups, and basically I don't pass the decoration objects. So this is how you can deal with groups inside of a Godot project doing a RTS type of project. And I think this is going to be very useful for AI stuff. So this is everything I have to show you this time. So I did a little bit less progress, but progress is progress nevertheless. And hopefully I can display you something more interesting on the further tutorials. I'm really excited to finish the AI stuff because I think that is a crucial part of the game. So having said that, this is where I sign off. Thank you for watching, and hopefully I'll see you on the next video.